I would like to improve the ArrayList implementation that we did so far by providing proper header files, or one proper header files. And I would say we can, well, just create a new file called ArrayList.h. And in this new file, we can define all these methods right here, like this. And the implementations the implementations have to stay here, I think. Yep. And then we have to include this, the array list here, include, I think this does not work because this is not a system library. Let me just try to compile this. It does not work. No such file directory. I think this will work. Yes, this works. What's the difference between these notations? C include angle brackets versus quotes. It's compiler dependent. That said, in general, using quotes prioritizes headers in the current working directory over system headers. Yeah. Usually angle brackets are used for system headers from to the specification. Okay, so my assumption was correct. And we have to, just to do things properly, we need to do a protective mechanism, that is C header if def, something like that. Header guards, yeah, right. C header guards. These C header guards are defined, or are there to ensure that a header is only included in the source file once, because technically you could do include standard.io.h and then include ArrayList.h, and then you would, let's say standard.io.h, which of course is not the case, but let's say standard.io.h, if you look that up, standard.io.h also includes ArrayList.h. Then the contents from ArrayList.h would be copied into the C file twice, which will produce a compilation error, which is not what we want. So this is overprotective right now because we're including just one tiny file here. Anyways, I would like to do this properly also for learning purposes. And yeah, okay. If not defined, array list header, then define, it's written out, define array list header, delete this right here. And then end if here. Yeah, that's it. End if, delete this. I think this should be it, and this should compile. Yes, it does. And if we call ArrayList, then the printout still looks good. What's even the point of these headers, of these prototypes? That's something I never really got in C. What's the point of C function prototype? prototypes. The C function prototype is a statement that tells the compiler about the function's name, return type, and data types of its parameters. Yes, of course, but that is also achieved by the method signature that is already embedded in the C file. By using this information, the compiler cross-checks function parameters and their data type with the function definition and function call. What's the point of function prototyping? Function prototyping originally was not included in C. When you called a function, the compiler just took your word for it that it would exist and took the type of arguments you provided. If you got the argument order, number, or type wrong, too bad, your code would fail. Well, I can still check that using the regular function signature. Later versions of C added function prototyping in order to address these problems. Your arguments are implicitly converted to the declared types. In C, prototyping is needed so that your program knows you have a function called X when you have not gotten to defining it. That way, Y knows that there is and exists a X. C does top-down compilation, so it needs to be defined beforehand is the shorter answer. This answer completely misses the point. You can call any function also without a prototype in scope. Yeah, that's my point. And before it's defined. Second top-down compilation. I believe it's part of the language specification and design philosophy. Requiring users to declare things before using them isn't a bad idea. It's a simple syntactical requirement that keeps devs on top of their code structure. After spending a few years working mostly in Python, I have to say that I appreciate languages that don't let devs get lazy, even if it's an inconvenience, especially when copy-pasting code. And C force you to be disciplined, and I prefer it. Well, okay, let me just accept that. So now we have a header file, ArrayList.h, and a C. Well, a C file. Can we now create another function, another C file? Oh. I will yank this into R, the entire main method. Now I would like to keep this clean. So this is the implementation of the ArrayList, and this is the ArrayList header. And now I would like to create a main or a test C. And test C executes the main method, and it includes ArrayList.h. No, that doesn't work. ArrayList.h. Like this. Does that work now? Probably not. Because I would expect that the point of the header is, well, to embed the implementations here, but actually what it probably does is just copy the definitions here, but the implementation is going to be missing. So that is likely something where we have to tell the compiler some more information, but let's try it. Yeah, correct. So there's an error, undefined reference to main. Oh yeah, because we need to compile main C, and we need to compile main.c to main. it's called test. Okay. We need to compile test.c to output test. And that's what I was talking about. We now get a couple of undefined references that are called in the main function here. We have we have embedded the header file, but there's no implementation for the header. So how do we connect these things now? cc help header. I think I've heard of something called linking. C linking. Compiling and linking. When programmers talk about creating programs, they often says it compiles fine. This colloquial usage might later be a source of confusion for new programmers. Compiling isn't quite the same as creating an executable file. Instead, creating an executable is a multi-stage process divided into two components: compilation and linking. In reality, even if a program compiles fine, it might not actually work because of errors during the linking phase. The total process of going from source code files to an executable might better be referenced to a build. Okay. Compilation refers to processing of source code files. We have valid source code files, so that is fine, and they are compiled to assembly or to machine language. This step does not create anything the user can actually run. Instead, the compiler merely produces the machine language instructions, as I just said, that corresponds to the source code. For instance, if you compile 3 separate files, you will have 3 object files created as output, each with the name .o or file name .object. Each of these files contains a translation of your source code file into a machine language file. But you can't run them yet. You need to turn them into executables. That's where the linker comes in. Okay, but there's no further information on the linking. C compile header and C file. Here, this guy provides multiple files for compilation, so maybe that's what we have to do. So we're going to create output test. That's the binary, and we're going to embed ArrayList.c, ArrayList.h, and test.c. We have a binary called test now with a couple of warnings. Let's execute it and ignore the warnings for now, and we get a valid input. So by providing all the source code files, it seems to produce a valid input, but I'm not very comfortable with the warnings. Test C in function main, warning implicit declaration of function printf. Implicit declaration of function printf. Well, yes. Where? Okay, we have to include standard IO. That's what even the compiler tells us. So here, the compiler detected that we're using printf and it automatically included standard IO, but of course this is not the proper way to do it. We should include it ourselves. Standard IO.h, like this. And this compiles fine now. And let's try to run that, and this is a valid file. Can we compile only the an ArrayList binary using ArrayList C and ArrayList H. No, because there's no reference to main. But then, how do we program pure libraries which just provide functions? Do they always have to provide a main method? Technically yes, because, well, are there really libraries, or are libraries just compilations of object files and maybe header files, which you can then link together? Maybe that's the case. Anyways, I'm quite happy with this now, with the structure now, because we have now separated out the testing itself using the main function, which is quite ugly. Then we have the ArrayList header, and then we additionally have an ArrayList C implementation. So that is quite nice, I think. And I would say I'm happy with that. Is there anything else we should do? We have now split up the program into separate headers, which is good. Separate objects. I just noticed that we are including standard.io.h here and also in a test function, but I think this is fine because likely standard.io does also have these header guards defined. So there's nothing for us to worry about now. And now we have an array list, or at least a header that defines a list. The list has a size of 1000. It might be good to make it variables somehow, but I'm not sure how that would work out. We have an add function, a get function, print array, and remove element, and they all operate on this data structure. We have to maybe the print array should not receive a copy of the entire data structure, but also work on the reference on the pointer, struct list pointer, like this, and then we can provide the current end like this, and access the array like that using the arrow operator. Let's see if that works. We have to provide the right compilation command. That does not work. Why? It's not happy with the struct list pointer. Incompatible type for argument 1 of print array list. Yeah, of course, we have to also update the test. And we have to look for where that is used. It's used here. Place the ampersand before the list to refer to the address. And do the same here as well. And down here. Okay, I'm sure this will compile now. And it did. And if we call test, then that works out. And I'm quite happy with that. That is actually the first real C product I coded. I know it's very simple. It's just an array list implementation, or just a list implementation that is limited to 1000 entries. But I am still happy with how it's separated out the testing and, well, this execution here and the actual library. One thing that I would like to do as well is to somehow dynamically provide the size of the array. C struct array size compile time. I would like to define it at compile time. I suggest that you define a type for each size of object that you want. That's also a quite nice idea. I mean, we could make small lists of 1,000 elements and then larger lists of 100,000 elements. Do we have to limit the amount of elements at all? Or can this just be a pointer? Oh, I think we have to limit it. C array increase size. There is no way to change the size of an array dynamically in C. You just have to define a new array and copy everything. Yeah, that was my idea. This goes for arrays in stack and kind also for a heap. On the heap you have to reallocate a new memory block either with malloc and free. How can I change the size of an array? Well, they are static, so that doesn't work. Maybe we'll do that in a different episode. For now, I'm happy with what we got. See you next time. And please leave a like if you enjoyed watching me code these header files and familiarize with these new concepts a bit. And if you also learned something even better, then see you next time. Bye.